Welcome to activity 7.3. Does the Earth's shape affect temperature? So you should be on page 68. Learning target for today is we're going to determine if the shape of the Earth affects temperature at different locations. Now the expectation for you is you will examine the data and complete activity 7.3. So look at the top of page 68. Using what you know about the Earth's shape and how it's heated, why do you think that temperature varies based on latitude? So go ahead and make a prediction. Using what you know about the Earth's shape and how it's heated, why do you think that temperature varies based on latitude? If you need to pause the video, do so. This should be a pretty good solid sentence. All right, so now you've had a chance to do that. So let's take a look at what we already know about light. We know that light travels in a straight line. Light does not bend. It does not go around corners. Light can be absorbed, like for example, the Earth absorbs light. It can be scattered by things like clouds, and it can be reflected. We also know that light energy from the sun is responsible for heating our atmosphere indirectly, because that light energy is absorbed by the Earth's surface, then through conduction that heat's transferred to the atmosphere, and then when that part of the atmosphere that's in contact with the Earth heats up, then we have convection taking place. So all this increases the thermal energy of the air. Now, if you look on page 69, you guys are going to be filling in this data table. You can ignore all the procedures. I'm actually going to give you the data. And the reason I'm giving you the data is we don't have light meters. So this was the only activity that required light meters. So instead of spending thousands of dollars on light meters, we decided to take our iPad. So I took my iPad from home and I downloaded a light lux meter. And what I did was I put that light meter on my table, and it was during the day, and I used my window to represent the sun. So I set my iPad straight up, so that would be representing 0 degrees latitude. And the reading I got on my lux meter was 461. So go ahead and record that for 0 degrees latitude. So remember, 0 degrees latitude would be the equator. Now, I tilted it back a little bit. Actually, I tilted it forward. I didn't tilt it back, but I tilted it forward a little bit to 80 degrees from straight up and down. So that would represent 10 degrees latitude, and I got 261. So go ahead, record 261 for 10 degrees. For 20 degrees, 99. For 30 degrees, 46. For 40 degrees, 19. For 50 and 60 degrees, I got 19. It didn't change. And for 70 and 80 degrees, I got 0. Now, the day I did it, it was a little overcast. It wasn't bright and sunny out, so that would definitely change the reading. So you can download a light meter for free. I got it for free. And you can see what you get for readings as well. You could have set up a lamp to simulate the sun, and you could do it that way. So when you look at those numbers, do you notice any patterns? So look at number 1. Was there a pattern in the intensity of the incoming light and the latitude of the pins? Now, we didn't use pins. So how about with the lux meter? Do you notice a pattern? So for number 1, was there a pattern in the intensity of the incoming light and the latitude? So don't worry about the pins. So you should have seen that at the equator, it got a lot more light. And then as you go further and further away from the equator, you get less and less light. And the reason for that is the curvature of the Earth. So I got a few more slides for us here. So again, we talked about this energy budget. We talked about how approximately 45% of the energy coming from the sun is absorbed by the Earth. And ultimately, that's what heats our atmosphere. Now, we also have talked about how the Earth, it's tilted. And eventually we're going to get into the reasons for the seasons, and that's going to be coming up as well. So we know that there is a tilt of the Earth, and we know that the Earth is curved. And when you put all these things together, they definitely have an impact on the temperature at the various locations on our planet. And here's a good slide that will show you that. So if this was 0 degrees latitude, so here's 0, and so we would see that on the chart. Look, all this sunlight is coming in. Now, sometimes people say that down here you get indirect sunlight. No, we get direct sunlight. I guess the only indirect sunlight we might get is on a full moon. The sun is reflecting off the moon, coming back down to the earth. Otherwise, we get direct sunlight during the day. But because it's not as curved here, look how big this area is. And we're going to cover this in our next lesson as well. But if you notice up here, it's got to cover a much, much larger area. So that's the reason why there are so few lumes or light at the higher latitude. So here would be 60. So 90 would be right up here. We didn't get 90 straight up. They went to about 80, which would be about here. Remember, at both 70 and 80, we got 0. Doesn't mean there won't be any light. It's just the on my iPad, the app didn't pick any lumes up at that point in time. So for number 2, it says, use what you know about light. Draw a diagram of how light rays from the sun hit the earth. Be sure to include the earth and the sun, the equator and the axis, the light rays from the sun. Make a label showing where the light was most intense in your data and a label showing where the light was least intense in your data. So what I'm going to do is I'm going to show you a model, and feel free just to draw this model outright. We're doing this on a Wednesday. If you want to practice drawing it yourself, you can. If you want to quickly sketch and think to yourself, okay, this is what I would draw, then I'm going to show you what I think you should have. And you could see if there's any similarities, but if you need to go right to the model, go ahead. So here it is. So you have the earth and the sun. Is this drawn to scale? No. So you don't have to draw the sun that much larger than the earth. Now you have the equator and the axis. What I'm looking for in the models, and you may have to do something like this on a test, or you're going to have to interpret a model like this in the test. I would be looking to see if this is at an angle, or did you draw it straight? So I'd be looking, do you know that the earth is tilted? Light rays from the sun, so you'd want them coming here. And what I'd like you to do is have a label showing where the light was most intense on your model and least intense. So if we were to back up to this, remember at 0 degrees, it was 461. So if we back up to the model, 0 degrees right here, because there's Earth's tilt, would be straight away. This is where it would be. And that's why it's the most intense. So again, on the test, you may have to draw something like this, or I may give you a diagram and you may have to put some labels on it. Maybe I'd have you draw an equator just to see if you remember that it's at an angle, which is approximately 23.5 degrees. Do remember that the poles are diagonal here. It's not straight up and down. Would you know how to draw where the most intense part is and the least intense part of it is? All right. So make sure you have that model in. Now, number 3 says, do you have any ideas that could explain this relationship? What questions do you still have? So do you have any questions about what we talked about today? It's a quick activity, which is great because it is a Wednesday, so you're going to have to finish this up quickly in the time that we have. So again, make sure if you have questions, some of this material will be on the test, so you can ask. Thanks. Bye.